In this very lesson, we shall be looking at the two-set problem. But before we start with the actual calculation, then we should be able to identify and describe the regions within the Venn diagram, because the identification and descriptions of the regions in the Venn diagram plays a key role in solving questions under two-set problem and then three-set problem. Now, I believe that at this very stage, each and every one of us can represent sets on the Venn diagram like this. Good. So this Venn diagram here is going to serve as a guide to enable us to describe the regions within the Venn diagram. Remember, this is what a duplicate of this Venn diagram is. I mean, this is the same as that, but just that I have represented the regions in this particular Venn diagram with what the Roman numerals. So this is going to serve as a guide to enable us to identify and describe the regions in the Venn diagram. So let's start. So we have the universal set which contains the elements. These elements, we also have a subset of the universal set, set A and then set B, and then we have an element that belongs to the universal set, but they are not part of this set A and then set B. Good. So if I ask you to list the element for A intersection B, I believe we can do that. And we know that A intersection B means that we have to look for those elements that belongs to A and at the same time belongs to B. And from this diagram, we can see that it is 2 that belongs to A and at the same time belongs to B. So this region is called A intersection B. So we can say that I is called A intersection B. It means that I belongs to A and at the same time belongs to B. Good. If I ask you to list the element for A, I mean the element for A, I believe you are going to say that the element for A are 2, 4, and then 6. So we have 2, 4, and then 6. So it means that the whole of this circle belongs to A. So the element for A, we have 2, 4, and then 6. Also, if I ask you to list the element for A only, the key word is what? Only. Meaning that you don't want any element which belongs to B to be part of what? A. So we call that A only. So if you have to look at this diagram and I ask you to list the element for A only, I believe you say that the elements for A only are 4 and then what? 6. So it means that this region is for what? A only. Meaning we don't want any element from B to be part of what? A. So that is that for this region. So when you transfer it here, the region for A only is going to be what region? II. So A only. That is what this particular region, A only. So this region is what? A only. Now let's look at this set notation. If I ask you to list the element of A intersection B complements, A intersection B complements, we want to list the element of this particular set. But before we can do that, we have to first find what B complements. So we have B, okay, let me write it here. B complements, meaning we have to look for all those elements that belong to the universal set, but they are not part of what? B. And we are going to have 1, 4, 6, and then 7. Now we have B complements. Let's find A. The element for A, we have what? 2, 4, and then 6. Now we can find what? A intersection B complement. So from here, do we have a common element? We have 4 and then 6. So realize that the element in this particular set is the same as the element in A only. So you can therefore say that the region A only is the same as what? A intersection B complements. So if you don't see A only and then you see A intersection B complement, it means the same thing. We are talking about this particular region. If I ask you to list the element for B, the element for B, I believe you are going to say the element for B, we have 2, 3, and then 5. 2, 3, and then 5. Now, what about B only? Meaning we don't want any element from A to be part of what? B, and those elements becomes B only. So from this very diagram, the element for B only, we are going to get what? 3 and then 5. So it means that this region is for what? B only. So when you transfer it here, this region is called what? B only. So region I is called B only. Now, what do you think will be the set notation for B only? I believe you are saying A complement intersection B. Very, very good. That is that. So this region is called B only. This region is called A only. This region is called A intersection B. I guess you are following. A union B or complement. What do you think this element for this particular set will be? Now, before we can find A union B or complement, we have to find A union B. Meaning we are going to combine set A and then set B into a single set, right? So we are going to have, now that we have A union B, we can find its complements. So we are to look for all those elements in the universal set that are not here. And I believe you are saying 1 and then what? 7. Therefore, A union B or complement is what? 1 and 7. And we can locate it here. Which means that they belong to the universal set, but they are not part of what? Set A and B. So this region is called A union B or complement. So when we transfer it here, the region IV becomes what? A union B or, so these are the names given to the regions in the Venn diagram. Once again, let's go through them again. Now the region I is called the intersection of these two sets. We call it A intersection B. Now the region II, which is this particular region, is called A only or A intersection B complement. Now the region III, which is this particular region, is called B only or A complement intersection B. And then the region IV is called A union B or complement. So these are the names given to this region in the two-set problem. Good. Now that we have been able to identify and describe the regions in the Venn diagram, let's look at the relationship between them. So still we are back on this. It's still going to serve as a guide to enable us to identify the relationship amongst the region. Now if I ask you to find the universal set from this particular region, from this particular diagram, what are you going to say? I believe you'll be saying that to find the universal set, we are going to add this region, this region, this region, and this region to obtain the universal set. Similarly, to get the universal set from this diagram, we are going to add this region to this region, and then this region to give us the universal set. So we can say that U is equal to region I plus region I plus region I plus what? Region IV. Now we know that region I represents what? A intersection B, right? So we can say A intersection B plus region I is what? A only. So we have A only plus region I is what? B only. And then plus region what? IV is called. So this is the equation that is going to guide us to solve problems on two-set problems. So we have the first equation. Let's look at the next equation. So we have first equation. Let's look at the next one. Now, assuming that region 4 is 0, region 4 is 0, and then I ask you to find A union B. A union B. I believe to find A union B, we are going to add this region, and then this region in order to obtain A union B. So we are going to get region I plus region I plus region what? I. So these are the two formulas or equations that is going to guide us in solving questions on two-set problems. This brings us to the end of today's lesson. See you tomorrow on questions on two-set problems. Bye-bye.